Okay, in this video I teach you how to find the p-value. This is the p-value method. If you want to apply it, you need to first find the p-value. And I give you four problems, two of them about the z-test and two about the t-test. But you will notice that all of them are different questions, because the first one is a two-tailed z-test and you have a negative test statistic. The second one is a right-tailed z-test and the test statistic is positive. If in this case it doesn't matter, but for the two-tailed test it matters whether it's negative or positive. And then we have a two-tailed t-test, you have the n, and you have the test statistic t negative, and another two-tailed test, you have n 21 and t is positive. Okay, so we will start solving them one by one, and at the end of this video I assure you that you'll understand how to compute the p-value for any type of test, whether it's z or t, two-tailed, right or left-tailed. So let's go to the first one. Determine the p-value for a two-tailed z-test if the test statistic z is negative 2.19. So you look at the table that I have. This table, you need to know it by heart, yeah? And so you look in the table, what is the situation that I have? It says it's two-tailed, so you see you either have to choose this one or that one, but because the test statistic is negative, you immediately know that this will be your formula for the p-value. Notice the p-value is here. This is how you compute it. So it's saying that you have to use this formula for the p-value. So you can say the p-value for this question is equal to 2 times the probability that z is less than the test statistic, little z, which is given, negative 2.19. And so because it's less than, you can use the z table here, so this will be 2 times, and if you look at the z table and find the place where z is negative 2.19, you will get 0.0143. This is the area to the left of the z-score negative 2.19, as you know. Please check with the z table while you're solving this. And so if you multiply, you can use your calculator now, you'll get that the p-value is 0.0286. And now this is the final answer. That's the answer to this part. Let me just put it in red. Okay, so this is our answer to this part. Let's go to the next part. But before I go, notice that this z that you have is negative. If it was the positive, then of course you will be using this one here because it's a two-tailed test. If it was, instead of 2, we said left-tailed test, for example, then of course you will be using the left-tailed test formula for the p-value. Okay, so this is how you use this table, but I'll do another example. So let's go to part 2. Determine the p-value for, now they're telling you a right-tailed z-test if the test statistic, and then they give you the test statistic here. So right-tailed, it means that you are using this here, the upper or right tail. This is the same. So the formula will be the one here for the p-value. Remember always, the p-value takes one of these 4 formulas depending on the given. So in this case, we have a right-tail test, so it shows the part that has right tail, and then this is our formula for the p-value. This is the formula here for the p-value. So you can say, in this case, the p-value, the formula is, because it's a right test, so maybe we can say even here, because it's a right-tailed test. So right-tail, it is the probability that z is bigger than the test statistic that is given to you, which is 2.19. Yeah, this is what's given at the beginning. And so, because this is probability of z bigger, it will give you the area to the right. So to get the area to the right, you need to do 1 minus the area to the left, which is probability of z less than 2.19. And now we can use the z table here, and I will leave it for you to do. So this will be 1 minus, and then of course this is something that we can use the z table for. So look in the z table for z 2.19, and you'll find that the area to the left of it is exactly 0.9857. And so if you use your calculator, you'll get that 1 minus this is equal to 0.0143. And again, I will use red to highlight this. So our p-value now is here. So now I hope that if you get any problem about computing the p-value for a z-test, then you will be able to solve it. It's all from the z-table, and you just have to know which one of these 4 situations you're in. And this is from the question. Either it's two-tail and z is positive, or two-tail and z is negative, or it's a right tail or a left tail test. So you now understand how to do it. Let's go to the next question, and this one is about finding the p-value, but for a t-test. So in this case, we will use, of course, the t-table. But before using it, let's see what we're given. So we highlight that it's a two-tailed t-test. The sample size is 18, and we know that because of a t-test, if the sample size is 18, then you immediately compute the degrees of freedom, and this is n minus 1, which is, in this case, it's 18, and subtract 1 from 18, you get 17 degrees of freedom. This is very important to know. And the test statistic is this t. And because we know that in the t-table, all the values of t are positive, so we will look for, this is what we will look for, because we know that the t-table has all positive values, but for left tail test, we take the negative value. Please watch my part 3 video on hypothesis testing. You will understand this. So we will look for t equal 2.123 with the understanding that it is the negative. Yeah, it is the other part of the table that we don't have. Okay, this is always, you do this with the t-table. Please watch part 3 again. So now, this is the t-table, and of course, I took a screenshot of it up to the 17, because this will be our degrees of freedom. And remember, it was a two-tail test, and what was the t that we were given? T was negative 2.123, but we said that we will look for t equal 2.123. This is just from the table. This is the value that you will look for. So now, 2 tails and 17. So you move with 17 until you get to where 2.123 is. But you notice that you arrive here. This is 2.110, and this is 2.567. And the t that we have actually lies between them, somewhere in here, between these two. So what we will do now is go up with the table from this value and take this number that you see here, and go up and take this number that you see here. Of course, you take the numbers that go with the same test that you have, because we have a two-tail test. If it was a one-tail test, then you will keep on going up and take these values, okay, to match your test. One tail means left or right tail. But in this case, we have a two-tail test, so this is what we do. And now we know that our p-value is going to be here. So this will have our p-value. We cannot determine the p-value precisely from the table, but we can approximate it. So you can say, therefore, my p-value, I can definitely say that it's between the two numbers that you see here. But notice that these numbers, the 0.02 is the smaller one of them. So you say this is 2%, which is 2 over 100, and the other one is 5%, which is 5 over 100. And so my p-value is between these two. Just make sure that you see that this number here, okay, look up, this number is less than this number. So don't say the p-value is between 0.05 less, I mean, don't put this one here and this one here. It will be wrong if you do that. Notice that the numbers, as you move from here to here to here, they are increasing this way. Okay? This is just a formality, but it's very simple for you to see. Okay? All of us agree that 0.02 is smaller than 0.05. So now this is the answer. When you have a t-table, you cannot find the p-value precisely, but you can say at least it's between these two values. And those two values that you found are, by looking at the type of test, two tails, the degrees of freedom 17, and we moved until we found where our t is. Of course, we were given a negative t, but we know that the table doesn't have negative, so we take the positive of it and then look in the table and find the two values that it's between, making sure that we are with the same degrees of freedom. This is a problem that some people have, is that they look in the whole table to find this number or this number, you know, but it's wrong. What you need to do is find the degrees of freedom, and in its row, you approximate your t. You find it's between which values, and then once you find the two values it's between, you go up to the type of test that you have. In this case, it's a two-tailed test, and take the two values that you have here and say that the p-value will be between them. And just again, remember that the values here, 0.01, then 0.02, 0.05, 0.10, 0.20, they are increasing in this order. It's like this increasing. So when you write the p-value, you say, you put the 0.02 before you put the 0.05. Hopefully by now you got it perfectly, but I will do one more question. So here, estimate the p-value for, again, a two-tailed t-test. We have n is 21. Immediately I want to say this means that the degrees of freedom is 21 minus 1, which is 20. So this is very important. So we know which row in the t-table to look at, and they gave us the t. It's 1.923. So here I will immediately say that t was 1.923, okay? And it's again a two-tailed test, and n is 21, so df is 20, the degrees of freedom. And let's look for, we keep on moving until we find 1.923. So it is, actually, yes, it is between this number and this number. So this becomes here, in between these two. So immediately you will go up and go to the type of test. It's two-tailed, so I stay in the row of the two tails. See, it's here. And then my p-value is between these two numbers. So here it will be my p-value. So I will finally say, therefore, my p-value is between, of course, if you remember what I did in the past, in the previous problem, it's you put 0.05 first and then 0.10. And so this is the estimation for our p-value. Notice, again, for the t-table, you estimate the p-value, but for the z table, you get the exact value of the p-value, because we have the z table, and the z table contains everything. Our t-table is a little bit short of values. We need more values. There are calculators that can get you the exact p-value for a t-test, but we prefer that you just use this table and approximate it for now. Later, when you learn more statistics, you will know how to find the exact p-value for a t-test. And I will stop the video here.